Let's look at a couple examples that will help you get an idea of what kind of problems you'll see on your Section 2 quiz. So the first thing we talked about was how to solve quadratics. So we have a couple examples of some different quadratics we want to solve. And the big ways we did that was either by factoring, by square root method, or quadratic formula. So I would always look to factor. And if I look at this first one, x squared plus 4x minus 4, I can definitely see that that factors. This is x plus 5, x minus 1. Because two numbers that multiply to negative 5 add to 4. Now you certainly could use quadratic formula on here, but pretty easy to factor that one. So we have x plus 5 equals 0, x minus 1 equals 0, because those are our two factors. So x equals negative 5 and 1. Now the second one is kind of screaming out to do square root property because first of all there's no x term, and when there's no x term that's a pretty good clue that it would be a good idea to try to do the square root property by getting the x squared by itself and taking the root of both sides. To do that I'll have to divide by 2 first, so that gives me x squared equal 8. And then just remember when you take the square root, you have to add the plus minus. So x is going to equal plus or minus square root of 8. If I simplify that, 8 breaks down to 4 and 2, 2 and 2. So we have a pair of 2's that would come out of our root. So that's plus or minus 2 times the square root of 2. Finally, this part C, this might be factorable, but I don't really even want to try it. Too big of numbers, too bizarre ones to factor. So I'm just going to use quadratic formula. Negative b plus or minus the square root, b squared minus 4ac, all over 2a. So that's going to be negative negative 6, which is 6, plus or minus the square root, negative 6 squared minus 4 times a times c all over 2 times a. So what I would do to simplify it is I would work everything under the square root to see what that is. So what is the negative 6 minus 4 times 4 times 7? So when I do that I get negative 76. So I have to try to simplify negative 76. So I know that when I'm simplifying it, it's negative, so I could definitely take an I out. So I have 6 plus or minus I. And then I'm looking for a perfect square that divides by 76. And I know 76 is 2 times 38 and 2 times 19. So I have a pair of 2's. The 2 will come out, and 19 will be left, all over 8. Now to simplify, remember, if you look at the 6 and 8, they both divide by 2, but you also have to divide this one by 2 as well. You have to divide all those numbers to simplify a quadratic solution. So this is going to be 3 plus or minus I root 19 over 4. So this one has two complex solutions to it. Second problem, the second thing was talking about dividing polynomials. So I want to divide these two polynomials, x to the 5th minus 7x squared plus 1 divided by x minus 2. Pretty simple to do. I would do it by synthetic division because we're only dividing by that binomial factor. So I'd put the 2 outside and then the coefficients on the inside. So 0 for x4, 0 for x cubed, minus 7 for x squared. 0 for x to the first, and then 1 for the constant. 1, 2, 0 plus 2 is 2, 2 times 2 is 4, 0 plus 4 is 4, 2 times 4 is 8, negative 7 plus 8 is 1, 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 1 plus 4 is 5. So remember that last number is always our remainder, and this always goes 1 degree less than what we started with. So this is x to the 5th. So our answer should start with x to the 4th. So x to the 4th plus 2x to the 3rd plus 4x squared plus 1x plus 2. And then the remainder is 5, and we generally just write the remainder over the divisor. So it's 5 over x minus 2. There you go. Okay, question 3 wants to know which of these are factors of x cubed plus x squared plus x plus 1. And we've seen several ways to do this. We could look for intercepts. We could look and see if any of the zeros are intercepts. We could plug in and hopefully get a 0, because the factor theorem says if you're a factor, if the remainder is 0, and if you plug in a number, it's the remainder. We could also long divide each of these. We could divide all those and see which of them gave me a remainder of 0. So all these are good methods. I'm just simply going to plug the 0 in and see what I get. So if I get a 0, it'll be a yes. If I get anything else, it'll be a no. So I'll plug in 1. So 1 cubed plus 1 squared plus 1 is 4. So that's not equal to 0. So this is not a factor. It might be more efficient just to graph it so you could do all these at once, but it's not a lot of work to plug these in. G of -1, so I'm going to plug -1 for each one. So -1 cubed plus -1 squared plus -1 plus 1. So this is going to be -1 plus 1, because even powers, remember, take the negative away, plus -1 plus 1. So this is going to give me 0. So the answer to this one is yes, it is a factor, because the remainder is 0 upon division. And the last one, we have x minus 2. So the potential 0 would be 2. So I'll plug 2. And so that's going to be 2 to the third plus 2 to the second plus 2 plus 1. I can tell you already this is not going to be a factor because we have all positive numbers. So this is not going to be equal to 0, so not a factor. I don't really care what it is, but if it's not 0, it's not a factor. All right, so this one says, number 4 says, given f of 5 equals 0, factor x cubed minus 2x squared minus 13x minus 10. Now remember, since it's plugged in and gives you 0, we know that is a 0. So right away, we know x minus 5, x minus 3 is a factor. So lots of ways to do it, but we typically said we would divide out all the factors we know. And I know this one. Now, could I graph this whole thing and see if I could find the other one? Sure. But I know one, so I'm just going to divide it out. So I'm going to take the 5, and I'm going to divide out by 1, -2, -13, and -10. Let's bring down the 1. 5 times 1 is 5. -2 plus 5 is 3. 5 times 3 is 15. -13 and 15 is 2. 5 times 2 is 10. That leaves me a remainder of 0. And we'd hope it does, because if not, this really wasn't a 0. So since this is with a third power, we divided one time. This would be a quadratic, x squared plus 3x plus 2. So our other factor, we can just bring it up here. We know this thing factors as x cubed plus 3x plus 2. So now we've rewritten f of x. Now we could factor the pink polynomial, hopefully, and factor a little further, because we want two numbers multiplied to 2, add to 3. Very simple. That's 2 and 1. So it's x plus 2, x plus 1. So now we actually know all our zeros. Our zeros are going to be 5, which we already knew, -2, and -1. Finally, we have another polynomial, g of x equals x cubed minus 5x squared plus 2x plus 12. We want to list all the possible rational zeros and then find all the zeros of g of x. Okay. So again, we'll start with all the possible rational zeros. Remember, the rational roots are all the factors of p divided by all the factors of q, which in this case is really easy, probably too easy, because q is just 1, so it's just 1. And then the factors of 12 are 1 and 12, 2 and 6, because these are what multiply to 12, and then 3 and 4. And since we're dividing all those by 1, our list of rational zeros is quite simply 1, 12, plus or minus for all these, 2, 6, 3, and 4. So now, the second step in this is obviously to figure out which of these actually are zeros. These are all possible zeros, the only possible rational zeros, but which one actually are zeros for this polynomial? So the easiest, well, one way to do is plug them all in. Plug every single one of those possibilities in and see which ones works. Well, that does not sound very simple. So when I graph it, it crosses the x-axis, but it only crosses at one of the ones that we know, and that one happens at 3. F of 3 equals 0. Now the other ones, if you look on the graph, they're really weird decimal numbers, so they're not rational. This is the only one that's rational. So the other ones are either irrational or they're going to be complex, but we see them, so they're going to be irrational. So if I want, this is the only rational zero, and we're not going to do the irrational ones quite yet, although they're really pretty simple to do, but we'll do that after we take our quiz. So I'll go ahead and divide 3 out. So I divide 3 out into our polynomial, 1, negative 5, 2, and 12, 1, 3, negative 2, negative 6, negative 4, negative 12, 0. It was a cube, we divided out once, so this is a square, x squared minus 2x minus 4. So, sneak peek ahead, if you want to find the other zeros, we could just solve this quadratic as we did in the first section, but for now we'll just stick with this. So this is g of x, so I guess this should have been g up here, not f, but same difference. So now if I want to factor, I know one zero is 3, so that's x minus 3. And my other one is x squared minus 2x minus 4, which does not factor, so I can't really write it as a linear factor. So hopefully these examples give you an idea of what to study for your quiz on the first 3 sections of Module 2.